Okay, I'm down south, the project house, doing some filming and some work, which you'll see in upcoming videos. Just thought I'd introduce this video. So back when I started doing YouTube videos, one of my first ones I think was fitting all my media center and computers and such into a cupboard under the window. Part of that I put a UPS in, which is Uninterruptible Power Supply. What that means is if the mains fails, the grid, it keeps the computer running so that my cameras still work. I still have broadband for my phones and laptops. And also you can access the TV still, because as soon as the power goes off and it doesn't work anymore. So what I decided to do was put in some commercial UPS. First of all, Ali 800, which is about 600 watts power supply, which was okay, but it was a big and old machine. It only cost me 20 quid. That broke. Overheat, I think. Anyway, so I then put in a little 250 watt one that broke. So I thought, well, look, I'll see what I've got from when I used to build motorhomes. So I had a look, and I've got some really expensive gear just lying around. So I thought, well, let's make one out of that. So that's what this video is about. Taking equipment I've already got and making an uninterruptible power supply for the computer, the TV, cameras, and as you'll see, the lights, and then it just gets out of hand really. But anyway, hope you enjoy the video. I'll leave you to it. Here we are. So I found the boxes. So let's go through and have a look what we've got and see if we can come up with some project for it really. I've got an idea of what I want to do, but let's see anyway. Right, so first of all, what's in this box here I think is the, let's have a look. Yeah. So this is the main inverter and battery charger. It's a Victron Multiplus 24 volts. 3000 VA, 70 amp charger, 50 amp mains pass-through capability. Yeah, so I've checked online and they are about £1,500 to buy. Although this is an older one, you can still accept the software that we need for it. Anyway, that's that. So in the box, what are you doing? You know you're not allowed up there. Come on. Down, down. How did she even get up there? My goodness. No. Okay, so what else have we got? The battery monitor. So this is the smart version to go with the Multiplus. Not quite expensive. Some connection leads for it. A generator changeover switch in case you need it. Victron color control, the GX. It's about £500, I think, something like that. And then it's got the wireless adapter. What else? Programming cable. For the Multiplus and maybe the battery monitor as well. I've got a cut-off switch, the mega fuse, decent one. Yeah, very good, thank you. Various temperature sensors. Yeah, okay. So those we bought to fix the display on here, because this one. Hey, one of these didn't work, so we took it apart and put a new display, but I've got 4 spare for the oven. Okay, don't need that. We've got a DC to DC converter to 12 volts. That's probably going to be to power something, I can't remember what. Some lugs, 8mm lugs. Some heavy duty cables. These are 50 square mil, 50mm squared, crimped, properly crimped, which is good. Except that one. Why is that one like that? Various cables. Okay, so that's for if I was going to use more Victron devices to stop them, to terminate the bus if I was going to communicate. That's pretty much it, I think. Yeah. Communication cable for the Multiplus. Instructions. Okay, we're in the basement, so we're going to have a look at mounting this stuff that we found, and then I'll explain to you what it all does. Firstly, I went to one of the DIY stores, and they had this old piece of off-cut, €2, perfect. So I'm just going to screw that to the wall, because it's very difficult to screw individual things to stone. So if I fix this there, then to screw the devices on there is going to be a lot simpler. Okay, so that's it really. I'll get this mounted and I'll start putting some stuff on the board. I'll come back to you and explain how it works. Okay, so we've mounted the Multiplus on this backboard because it's really hard to get to the stone. So I'm just going to have a look now. We've got 2 batteries here. They are actually pretty decent. I've had a look at them. They're pretty old, but they work well for now. They've hardly been used. I just used it on my heater video, on my central heating videos. I'm going to clean them up, clean the terminals up, and have a look at the cables, see what we've got. Okay. Mounted the colour control. It's the brains of the system. I've got to put this battery monitor in, but it's designed to go into something and I don't have any space behind, so I'm going to have to find a box or something to put it in. Here we are. Got these 2 mounted. I had to put this in a box because of all the cables that goes around it, and I haven't got enough space behind the board, but that's okay, it's only temporary. So now we need to work out where the cables and the batteries are going to go. Okay, so now I've just lined up where the batteries are going to go. Putting the fuse in, disconnect switch, the shunt for the battery monitor, and I've connected in the cables there. So tough going, slow, but we'll get there. Okay, where are we? Seeing all that. So now I've got all the connections in. I've got the shunt, cut-off switch, mega fuse. I've left this connection off on the battery for now until it's ready to commission. I've just started putting in all the supplies for the monitoring equipment. I'm just going to run the cables up there now. Fortunately, because this is temporary as usual, I don't really want to cut all these cables and remake the ends up, because the next thing I'm doing is not going to be the same as this, so I need to keep the cables as long as possible. So it might not be as neat as it should be, but I'll do my best. Okay, so next I'm going to run the cables down here to monitor the battery state and see if we can get this section wired in. So let's explain what's happening. The positive and the negative from two 12-volt batteries in series gives 24 volts. The positive goes through the switch, through the fuse, and then directly into the inverter. The negative goes through here, through a shunt, I'll get back to that in a minute, and into the inverter. And now the inverter converts that 24 volts into mains 220 volts AC. This here measures the battery voltage, how much current is being taken from the battery at any one time using this shunt. So that shunt measures and then displays on this what power is coming from the battery. This is a bit more complicated. This is an interface which shows you exactly what's going on and then transmits it over to Wi-Fi, and you can get it anywhere in the world, find out what's going on. Okay, so I've just connected this, which now connects the two batteries together. And the only thing that's working at the moment is this, because this is actually connected to the battery before the main switch, but it has an own separate fuse, and there's a reason for that because of the sensing of the current. So that's all connected, that's working. Got to set it all up, but I just want to make sure that it's showing the right voltage. 25.86 is about right for a charged 24 volts. Yeah, so let's flip this main switch. I'll set you up just in case it goes wrong, then I can jump. So we want to see nothing on here because it's in the off position, but this might light up hopefully. Okay, let's have a look. No smoke, it's the best sign. Starting up, still 25.8, nothing here. Love it. That's it, simple as that. It's on and it shows the inverter is on. And then tomorrow I'll bring you back and we'll connect the AC side up, and then I guess test it out. Okay, so I've come upstairs, we've got the DC side working, so I just want to show you now. I managed to log in from my old login when I was when it was in the other house years ago in England, but it works now, so let's see what we can see. So this is on the phone, and you can get this information anywhere, and you can see the status just as if you were downstairs. Quite cool, really. Loads of different options. Dashboard, which is this. So we've got our display, the inverter, and the battery monitor. So far this is working well. You can actually have this so you, as if you were just downstairs using the device downstairs, but you can do this anywhere in the world. So tomorrow we'll do I've got a job in the morning, well not a job, but I'm going to help someone in the morning, and then we can do the AC system. Yeah, can we? I've got the parts for it. Yeah, we can do the AC system in the afternoon. So I'll see you tomorrow. Okay, good afternoon. Yeah, it's nearly 4 o'clock. I've had this set up for a couple of days. I've been busy, so I've got back to it. So although we've got the batteries connected up, everything working as it should, we've now got to connect the main side to it. I'm going to put the cables in, but before I do that, I need to move some of these around because I want all the top row to be protected by the inverter, so it's like a big UPS. But you can't have things on here that take a lot of power. So for example, this socket here, this breaker here is the office, which has got a fan heater in, and this is the water heater, which is also I think 2000 watts or something. So when those two come on at the same time, then that's going to be a massive draw on such a small set of batteries. I've also got the sockets down here, and that covers the washing machine, and the only thing in here really that we can power from this is the lights. But to be honest, I need to put all the lights somewhere, either all in this row or all in that row or all in that row. Make all the lights on one row. Right, so now we've got it all wired in downstairs, and we'll just conduct a few tests to see if this works. Firstly, I'll show you what I've got set up. So you can see here, this is a direct over the Wi-Fi connection to the control panel downstairs. So this will mirror exactly everything that we're seeing downstairs, and I can use these keys here to navigate through and change settings if I need to. Now that's a direct connection. On here, this is slightly different. So we've logged into Victron's remote management system, and you can see all sorts of different things going on. It's exactly the same, but this can be monitored from anywhere in the world. Okay, so you can see that we can monitor what's going on from here. Well, as well as you can. So what I'm going to do is simulate a power cut now. Okay, so to simulate a power cut, we'll just turn the mains off here. So suddenly this has gone into inverting mode immediately. The lights are off because they're not connected to that part of the system. Right, there you go. So we've got power going to the bottom bar here. So let's go upstairs and have a look. Let's just test a few things. That still works. Still works. And let's have a look in here. Yep. All still running. That's good, good sign. You can see that's charging. Let's put something on quickly. So that works, that's good. That's it. I don't think, no, kitchen lights don't work because they're not on anything, they're not on the bottom row. But here, they work. Bathroom lights and fan. Good. And then guest lights. Good. Let's go upstairs. So in the office, let's have a look. Good. So everything works from the battery, which is great. So let's have a look at the system. So at the moment we're providing 170 watts because the TV is now on, soundbar and all that kind of stuff. That's how much percentage we've got left. And this will show you the historical data. You can see that the mains has been cut, there's no input. And the fact that I can do this shows that the broadband is working. Again, here we go. It's working, and we can see that the wireless networking is working on the battery, and it's taking 8 amps. Okay, that shows how it's working, and my idea is to be able to do this for a good few hours. So what I'm going to do is do a test, keep the TV running, the lights downstairs, and anything that normally would be on, and then come back to you and let you know how long that ran for, and how much energy we can get from the batteries, and so basically how long a blackout can we deal with. So yeah, I'll get back to you shortly. Okay, so how did the test go? Well, let's have a look. Right, so I switched it on about 10 o'clock in the morning. Then it started to just power the standby loads of everything all the way down. All the way down till 7 o'clock. So that's pretty good. Around about 4 o'clock, I put the TV on and watch the movie, so you can see that the power consumption was greater. And then at 7 o'clock, I switched the charger on, and that quickly went up to 100% by 11 o'clock. Gave us roughly, I don't know, 7 or 8 hours of backup power. Would have been about a bit longer, touch longer maybe, if I hadn't have started watching a movie and put the lights on and all that sort of stuff, because the lights went on around about 5 o'clock. Yeah, that's it. So I think that's really, really useful. So that will power all the lights in the house, the TV, and all the sockets in the front room as well, in the event of a blackout for 6 or 7 hours, which is really, really good. And I can monitor it from anywhere that I need to, and switch it on and off remotely. Now, what I can also do with this is set it to charge the batteries overnight on the cheaper rate, and then use that during the day to power any loads. But this is all part of the solar system that I'm going to be installing later on. Okay, I'm going to head down south now, probably do the introduction to this video down there. So I'll see you on the next one.